Hello students, welcome back to MegaMind Mentor. I'm Honey. In this video, we are going to do exercise 1.5, question number 3 and question number 5. I have already made a separate video on question number 4. You can find its link in the description box and also in the I button. Now let us get started with question number 3. It says recall pi is defined as a ratio of circumference of the circle to its diameter, that is pi is equal to c by d. This seems to contradict the fact that it is irrational. How will you resolve this contradiction? To get started with this question, let us first recall that pi is actually an irrational number. Now, if we are saying that pi is an irrational number, you cannot express it in form of c by d. It means you cannot write it in form of a rational number because rational numbers are written in form of p by q, where both of them are integers, right? And the value of q is not equal to 0. So if we are saying that an irrational value is expressed in form of a rational number, so this is where the contradiction comes in. To resolve this contradiction, we can give a simple statement that nowhere in the question it is said that c and d are actually integers. If they are integers, then only they will form the rational numbers. But here, since it is not said that they are integers, it means that either c or d, one of them is an irrational number, right? You can give the second statement that both of them are irrational numbers, right? So when we are saying that either of them are irrational or both of them are irrational numbers, it means that on dividing these two values, the answer that we are going to get will also be what? An irrational number. Also, one more thing, keep in mind that whenever you add, subtract, multiply or divide irrational numbers, your answer will always be an irrational number, right? So this is how we solve this contradiction, by saying that either c or d is irrational or both of them are irrational, and thus the quotient on dividing them will also be what? An irrational value, which will be actually the value for pi. Now these kind of questions are not generally asked in the examination because these questions are just for your conceptual clarification, that you are aware and you know how the value of pi is said to be an irrational value, right? Now let us move to the next question. So the next question's link is in the description box and you will find it in the I button also. Question number 5, it says to rationalize the denominator of all of the given numbers here. Now, what do you mean by rationalizing? So if you see here, all the denominators are actually irrational numbers. Now we have to convert all of these denominators to a rational number, right? That is why it says to rationalize the denominator. So in place of all these irrational numbers, we are supposed to get the rational numbers. So let us see how it is done. Taking the first question, it is 1 upon root 7. So this is a small step that we can do is, first of all, write down the number and let us now multiply both numerator and denominator by root 7. When you do so, you are going to make the denominator as a rational number, because we all know root 7 into root 7 will give you root 7 into 7, right? And 1 into root 7 is root 7 only, right? On multiplying root 7 into root 7, so here you get denominator as a 7, one of the 7 comes out of the root, and here you get is a root 7. And this is your answer because you have made the denominator as a rational number. So 7 is a rational number. So this is where you're going to stop, and this is how you rationalize the denominators. Now let us solve question number 2, in which we have to rationalize the denominator, which is root 7 minus root 6. To do so, we are going to multiply this with its rationalizing factor, and its rationalizing factor is going to be root 7 plus root 6. right? So only the sign changes. This minus sign here becomes negative and the terms are going to be same. Root 7 remains root 7, root 6 remains root 6. So we are going to multiply both numerator and denominator with this rationalizing factor. So the term used for this term, which helps in rationalizing the denominator, is called rationalizing factor, right? Now let us solve it. If you closely observe, let us say this term is A, this term is B, this is again A because they are same, and this is B. So it looks like one of the identities A minus B is multiplied with A plus B, and it is equal to A square minus B square. So we are going to use the same identity in the denominator part. So root 7 whole square, which is A square, minus root 6 whole square. And in the numerator, this one gets multiplied with both of these terms, right? So we get here root 7 plus root 6. Now let us solve further. Nothing happens to numerator, but in the denominator, root 7 square becomes 7 minus root 6 square becomes 6. So we get here root 7 plus root 6 by 1. And 1 is a rational number, so we have rationalized the denominator, or we can just simply write it as root 7 plus root 6. Now let us find what was rationalizing factor for question number 1. Yes, so it was root 7. So for question number 1, root 7 was the rationalizing factor. Now let us solve the last two questions. Now coming to question number 3, in which you have to rationalize the denominator root 5 plus root 2. So we are going to multiply both numerator and denominator with its rationalizing factor, in which only the sign changes, which is in between the terms. So simply multiply the numerator with root 5 minus root 2. In the same way, root 5 minus root 2. So I'll keep this in bracket. And now this term is A, this term is B, this is A, and this is B. So again, it looks like the identity which we have already learnt before. So it is A plus B into A minus B, which is actually equal to A square minus B square. Now we are going to use the same identity. So root 5 square minus root 2 square. And in the numerator, 1 gets multiplied with both of these terms. So you get here root 5 minus root. Keep on solving. Root 5 square becomes 5. Root 2 square becomes 2. And numerator is as it is. When solving further, you get denominator as 3, as 5 minus 2 is 3. And numerator is root 5 minus root 2. So we have got a rational number or a whole number as the denominator, and this is where you will stop solving. Now coming to question number 4. In question number 4, we have to rationalize 1 upon root 7 minus 2. The method remains same. We will first write the question as it is, and we are going to multiply both numerator and denominator by the rationalizing factor. So in this case, the sign between two terms is negative, so it will become positive for the rationalizing factor. Multiply both numerator and denominator with them. In the denominator, again it looks like the similar identity. It is A minus B when multiplied with A plus B. We get A square minus B square. So it is root 7 whole square minus 2 square, and 1 gets multiplied with both of these terms. So root 7 plus 2. Now in the denominator, you get 7 minus 4 and root 7 plus 2 in the numerator. 7 minus 4 gives us number 3. So it is a rational number or a whole number which we were looking for. And you get numerator as root 7 plus 2. So this is where you are going to stop solving because we have rationalized the denominator. Now let us quickly do MegaMind wrap up. So what have we learned so far in this video? Rationalizing the denominator means making the denominator of a fraction simpler by getting rid of any square roots or cube roots. So in class 9th, you have learned how to get rid of square roots by rationalizing the denominator. To do this, we move the square root or the cube root from the denominator of the fraction to the numerator. So you must have observed that every time the numerator becomes an irrational number, right? So in this case, root 7 plus 2 has become an irrational number. Now, why do we do this? So this makes it simpler to add and subtract the fraction. So this is the application of rationalizing the denominator. Now coming to the second important term that we have learned, it is rationalizing factor, right? So rationalizing factor is the expression that is multiplied to the irrational expression to obtain a rational number. So for example, if I have this given question, it means I have to rationalize this. So it is root 5 minus root 3. So what will be its rationalizing factor? Just to change the sign in between those two terms. So negative becomes positive sign. That's it. So it is root 5 plus root 3. Hope this video was helpful. In the upcoming videos, I'm going to do the next exercises. So stay tuned and don't forget to like, share and subscribe. Thank you for watching.